I've written a program that's going to demonstrate many of the basic functions that you need to be aware of concerning one-dimensional arrays. I'm going to be working with a program that actually uses two one-dimensional arrays of integer, and I can create arrays of any number of data types, but in this case I've chosen to use integer, so I want you to understand up front that what I'm demonstrating is not restricted to the use of integers. There are also two-dimensional arrays, which look basically like tables where we have rows and columns that intersect, and I'm not going to demonstrate this. I'm going to be demonstrating the array that's probably used most frequently, one-dimensional array, and conceptually it's going to look something like this, okay? And as you look at that diagram, that may in fact remind you of the way I have described strings, as we have used the substring function to access individual elements of a string. And in fact, a string is an array of characters, a one-dimensional array of characters. So what I'm going to show you in many ways you've already got some background for. It's not going to be a totally foreign concept. But in this case, I'm going to have two arrays that I'm going to be working with. I've named one int array 1, the other one int array 2. And some of the basic things that I'm going to need to do include declaring the array, which much like a variable brings the structure into existence, gives it a name, and in the case of an array it's also going to specify the length of the array. I'll be working with class level arrays. You can create local arrays, but generally class level arrays are probably what you're going to see most frequently. And I have a telephone call that I'm going to ignore because I had previously gotten about 15 minutes into this and someone called me, so this time I'm going to ignore it. Okay, so if you hear a buzzing in the background, that's someone trying to call me. Alright, so another thing that we'll need to do once we create the arrays is put values into them. So I'll use the terminology populate arrays, which means to insert values into the individual storage locations, which I will refer to as elements of the array. Notice that when the array is created, as in the case of int array 1, it has a total of 1, 2, 3, 4, 5, and that's the value that I include in the declaration statement. But as the array is elements are accessed, they're subscripted with values beginning at 0 through n-1. And another thing I should point out is, just like strings have a length property, so do arrays. And so in this case, int array 1, if I want to reference its length property, I would refer to it as int array 1.length, and that would return a integer value of 5. So as I work with an array in program code, if I need to specify the overall length of the array, I don't necessarily have to refer to that with a numeric constant, but rather I can reference it by its length property, and you'll see how handy that is as we look at sorting and searching. Okay. So other things that I'm going to demonstrate here include, include how to print the arrays. I'm going to print the arrays in reverse order through list boxes just to make it interesting. I will be finding the sum of all the elements in both of the arrays. And I'm going to be performing two operations, one called a linear search, the other one called a binary search, that allow me to check the contents of the array to see if a particular value is in the array. Okay, so I'll show you linear search, and that's just kind of a brute force search where I start at one end of the array. If I'm checking to see if a value exists, then I check the element 0, and then if it's not there, element 1, and if it's not there, element 2, and so forth. So I start on one end, could be at the front end or the back end of the array, and work in a linear fashion, accessing each element along the way. So that's the simplest way to do it. For large arrays, though, if we're talking about arrays that have millions of characters, that may be kind of slow and inefficient, and there's another way of doing it where you can speed up the search tremendously if the contents of the elements of the array are previously sorted in either ascending or descending order. So if the array has values that are ordered, then there is another type of search that we can perform, and for large arrays it can cut down dramatically on the amount of time it takes to check to see if something exists. And I'll go through the details of that here momentarily. I'm also going to have you use this program, and I'll write a test question, and you'll have to write the program code to answer a test question based upon this example program. I'll be demonstrating how to use the Visual Studio Debugger along the way. Some of you, I think, already know how to use this, maybe most, if not everybody, but nevertheless, just so that you see it, and I know that you know how to use it, I'll be demonstrating with it in this example. And then finally, I'm going to show you how to implement a simple sort algorithm. And my implementation of the algorithm is going to be less efficient than the version that you are going to do. I'm going to have you rewrite this, make a slight change, and make it much more efficient. And I have shown the contents of the array initially, and I'm showing how it progresses through this sorting of the array contents step by step. I'll go through all the details of that whenever we get to that portion of the code. Okay, so the next thing I want to do is actually run the program, and it's kind of a busy interface. I just dumped everything on this form, so this is purely a program that's designed to teach basic concepts, but doesn't do anything of any real practical value. All right, so what do we got going on here? Well, if I run the program, one of the things I can do is populate the array manually. I can just poke values into the elements of the array. And I'm going to go ahead and put some values in here. I'll put in a value. I'll put in a value of 1, 2, 3, 4, 5. I've got it set up so that it'll only accept 5 inputs since the array has been dimensioned to 5 elements. Okay, so I'm going to go ahead and populate array 1, one of the 2 arrays I've declared, by inserting values manually through this text box. So I'll put in a value of 1, 2, 3, 4, 5. Okay, now I've got the program code, so it'll reject any other attempts, but I'm not going to demonstrate that. I'll display it, and I manipulated things so that once the data is stored in the array, and right now element 0 stores 1, element 1 stores 2, element 3 stores, or element 2 stores 3, and so forth. But when I display it in reverse order, and we'll look at the program code and how that works here momentarily. But 1, 2, 3, 4, 5. So you see that, and got another phone call coming in. Hadn't been anybody call me all day long until I started recording this, so I'll ignore it. If you hear the buzzing sound, that's me ignoring my phone again. I right now have an array in array 1 storing 5 values, 1, 2, 3, 4, 5. And I have another array in array 2, and in array 2 is also dimensioned to 5 elements, and I've got it designed so that when I click this button, I drop into a loop, and iterate 5 times, and with each iteration generate a random number between 1 and 10. So I'm going to go ahead and do that, and then it also displays those values. Okay, so it's generated random numbers, and in fact, kind of an interesting thing there, it has generated the value 1 3 times. Okay, so we'll look at the code, see how that works. I've got some more code that is going to go through all the elements of this array and sum them up and store the sum value here, display the sum value here. Got a mistake, copy and paste mistake here. It's also going to go through all the elements of this array. It's going to check each element, add them up, and show me the sum of, should be in array 2 here. So if I click there, it tells me the total value of all the elements in array 1 is 1, 3, 6, 10, 15, and it shows the total values in array 2 as 8, 9, 12, 13. Okay, so it seems to be counting correctly. I have a linear search. Okay, so, and it's going to be searching, the code that I've written here searches int array 1. So if I check for the value 2, okay, so I'll just take the value 2, search, it comes back and tells me it's found. If I put in something that is clearly not in the list in the array and check, it comes back and tells me it's not found. So the code here looks at all the elements of the array to see whether or not the value that I am looking for exists. Okay, and I have a binary search here, and so it should work too, and I'll put in a value of 2 here. Since these are in ascending order, this should work. Okay, so I'll put in a value of 4. It doesn't really matter what I put in, but if I put in a value of 4 here and check, it tells me that it found it. If I put in a value of 44 and do a binary search, it tells me that it hasn't found it. Okay, now it's really providing the same functionality as the linear search, but the way it goes about doing it, the algorithm that it uses, is way different. I also have a sorting algorithm, but since these are already in ascending order, the sorting algorithm is, oops, I put some breakpoints in here, is not really going to tell me much. Okay, and I wish I hadn't done that now, but I set a breakpoint right here. The sorting algorithm uses nested loops. Okay, so I have a for loop within a for loop, and actually in terms of flow of control, I have a one-way decision inside of this inner for loop, which is inside of this outer for loop. So what's going to happen is this inner loop is going to iterate n-1 times, and each time it iterates, it's going to check and see whether it needs to shuffle the values in the array. And once it's gone through n-1 iterations, it will drop out of the inner loop, and control will pass back to the outer loop, where the index variable will be bumped up, at which point it will re-enter the block for the outer loop, which will mean that it's going to restart this for loop all over again. So with every iteration of the outer loop, I'll be going through n-1 iterations of the inner loop. So that inner loop is going to be very busy. And along the way, with each iteration of the inner loop, I'll decide whether I need to change what's stored in the contents of adjacent elements in the array. And what I want to do is demonstrate what's happening along the way. So with the debugger set, I can keep track of what my index variables are. Okay, so right now I'm at the point in time where the inner loop is just completed its first iteration, where the outer loop is within its first iteration, and the array contains these values. Okay, and I told you it was already in sorted order, so this thing's going to go through a lot of looping around to only discover that it's already sorted. Okay, so I'll come back to this. I forgot I had that breakpoint in, so I really don't want to stop and stop and stop. So let's see if I can't stop the program from running altogether. And now return back to the form and take a look at the program code. Okay, so I'm going to look at, first off, the class level variables and arrays that I have declared. So I'm declaring 2 arrays, class level integer arrays, one named int array1. And again, notice the syntax on how I do that. I have to provide brackets after the data type, and much like I'm creating an instance of an object, I have to use the keyword new and specify the number of elements that I want the array to have. I've created a class level variable called integer variable called I, and I've also created a class level random variable called R. And so going back to the form, if I look at the program code where I input values manually into the first element of the array, let's see what that looks like. What it looks like is I'm going to be using my class level variable I, which was initialized to 0, so it should sync up with the first element of the array immediately. I have an if-else statement in here that's going to block me from trying to access the array beyond its bounds. Okay, so it's only going to allow me to access elements 0, 1, 2, 3, 4. And if I'm within bounds, it's going to take whatever's in the text box where I've provided the input, convert it to int 16, and store it in whatever the current element of the array is. Element 0 the first time I do it, and then it bumps up I, the class level variable. Then it's going to store the next input value into array element 1, and so forth. Okay, and so that should be pretty straightforward. As I look at how I am displaying the array, so it's one thing to enter the values and store them, but the user doesn't see them. Now if the user wants to see evidence that the array stores values, they can click here. And what I have is a for loop. So it's just a simple for loop, but notice how I have it configured. I have a local block level variable j, and I initialize it to the value that is equal to the length of the array minus 1. The length of the array is 5, so that translates into an integer value of 4. J is initialized to 4, and 4 would happen to be the highest element number that I'm legally able to access. Okay, so again, I'm using the length property here. Makes my program code a little easier than having to put in numeric constant values. I keep checking to see whether j is greater than or equal to 0, and I will be decrementing j each element along the way. So I'm starting at the back end of the array and putting that last element, the first iteration of the loop, I put the last element of the array, the fourth element of the value in the fourth element of the array as the first item in the list box. The next iteration, I take the next to the last element of the array, put it in the list box, and keep working my way down. And that's how I'm populating the list box with values, with the array values in reverse order. Okay. Assigning random elements. So another way to populate the array is to populate it with random numbers. In the button click event, I've chosen to create a private void type method called built-in array to and list. Okay, so if I follow that program code wherever it might be, it's in here somewhere. There it is. Okay, so what am I doing? I'm initializing j to 0, this block level variable j to 0 inside of a for loop, so basically everything's being done inside of a for loop. I check to make sure that j has a value less than the total length, so it doesn't go out of bounds, and with each iteration I bump up the value of j. So the first iteration, I'll generate a random number between 1 and 10 and assign it to the jth element of the array, which will be the 0th element, and it'll store the first random number in the first element of the array. Then j gets bumped up, generates another random number in the second iteration, puts it in element 1, and that just continues on and on. And then, let's see, I populate the array, then I assign the array values to the list box in reverse order. Okay, so you can see there's another for loop there, and I go through the process of accessing the array. Okay, it's an integer array, so I have to convert each element's contents to string when I add them to the list box. And I start with the highest element array, which would be 5 minus 1 would be element 4, and put it in the first item in the list, then decrement j, and then the second highest element in the array, which would be the fourth element, array element 3 would be the second item in the list, and so forth. So I'm populating that second list in reverse order as well. And then finding the sum. Okay, so I need to find the sum of two different arrays, and what I've done here is written a private return type method called SumArray, and I'm passing it in the first call array int array 1, and in the second call I'm passing it int array 2. So I can pass arrays as parameters, but I should tell you this, that arrays are large structures, and when they are passed by reference. If you understand the difference between passing by value and passing by reference, you recall that when you pass by value, you pass a copy of the argument, and therefore there are two values that exist. And when you pass by reference, you pass the memory address of the original memory location. Because arrays use so much storage, they are passed by reference. You're passing the memory address of the structure. So, you know, whatever that method does that you pass it to is going to have the potential to affect the array structure itself. So in my case, I pass the first array, and the method SumArray, wherever it might be, right here, receives a integer array parameter. Okay, so it has an integer array parameter. Notice the notation. I have to specify the brackets after the data type. And so then within the method, I have a local variable that I set equal to 0, and I go through every element of the array. So I'm going to iterate for the length of the array, and with every iteration I take whatever the current element is and I add it to array sum, and then I return array sum, so that when I call it the first time, I return the sum of the array, convert it to string, and store it in label 5. When I call it the second time with a different argument, with a different array, again it finds the sum and returns it to the place where the method is being called, converts it to string, and assigns it to label 6 in this case. So that should be fairly straightforward the way that works. The linear search. Okay, so linear search checks run one end of the array, every element thereafter, to see whether a value exists. Let's take a look at how that works. I have it set up. Now I could have used a while loop and gotten out of this earlier, but I decided to go ahead and do it kind of a simple way, so I could have been more efficient about this. I declare a local variable, local type bool variable called founded, initialize it to false. Okay, so sort of guilty until proven innocent approach. And then I input the value from the text box, convert it to integer, and store it in a local variable called val. Set up a loop that will iterate starting with value 0 going through the length of the array minus 1. So the less than is going to take me to the length of the array minus 1 times. With every iteration, I check to see whether the current element is equal to the value in question, and if it is, I set my bool from false to true. If it's not, the current element is not equal to the value in question, then the if is ignored. Okay, so I have a for loop, and I give every element the opportunity to change the value and found it. And then finally, when I come out, I check the local type bool variable found it, and if it's equal to true, I display one message. If it's not equal to true, if it never got in the if, then it will retain its value of false, and it'll take the else path and display not found. Okay, so there's the idea of a linear search, just starting at element 0 and checking the value against the current element, going to the next element, checking the value against the current element of the array, and so forth. Then we have the binary search, and I'm not going to go through this, in its full-blown glory. I'm just going to tell you how it works, and then I'm going to let you study the details. Okay, so if we look at the example here, all right, and this is not a good example. Let me go ahead and populate this guy. Okay, so we'll pretend this has a value of 2 and another value here. I'm going to make up some stuff. 4, 2, 4, 7, 8, and 10. Now, if I just put those values in, what I could say, looking at this, inspecting this, is that the array contains values that are in ascending order from low to high. Okay, and that's a prerequisite for doing a binary search, is that the array has to be ordered, and typically it's ordered in ascending order rather than the reverse of this, which would be descending order. All right, so let's pretend we're looking for the value of 8. Okay, so the code is set up so that it creates a variable called, I don't remember whether I called it L or low. Okay, that's what I call it. I called it, I'm using these local variables H, L, and M. Think of it as high, low, and medium. And I set high equal to the length of the array minus 1. I set low equal to 0. So H is going to have a value that corresponds with the maximum subscript value. L is going to have a value that corresponds with the minimum subscript value. Then I calculate M as being the int of L plus H divided by 2, calculate a middle position. So in the event that I have L equals 0 and H equal int array length minus 1, so it would be equal to 4, then I'd calculate a value of 2. Okay, and then what I would do is drop into a while loop. Okay, and I would test 3 different things. I would check to see if the value at position M is less than the value being looked for. If the value at position M, the calculated value, which would be 2 in this case, if the value is less than the value I'm looking for, that means that everything to the left is less than the value I'm looking for. And what I would do is reset my low pointer to be equal to the value of m plus 1, and I would then recalculate m, which would be the end of 3 plus 4, which would be 7. It would be 7 divided by 2, the end of that. So what would that be? That would be 3. It'd be pointing at 3, right? And so I would recalculate, and I'd throw away the lower half of the array and then just continue to look through the upper half. If I find that the value at m is greater than the value I'm looking for, then that means if the value of m is greater than the value I'm looking for, that means that this is going to be greater than the value I'm looking for. This means that it's going to be greater than the value I'm looking for. So what I'd want to do is set my high pointer equal to m minus 1 and then recalculate m again, okay? And effectively throwing away the top half of the array. So I do this over and over again. I look at the third test. Okay, the third test is whether it's equal, and if it is equal, you set found equal to true. Okay, and that would be a condition for getting you out of the loop. Okay, so what this is going to do is going to keep recalculating the middle and throwing away the top half or the bottom half until either it finds it or it's exhausted all possibilities and it eventually gets you out of the loop. But if you've got a 1 million element array, that means that in the first if you don't find the value in the first iteration, you will have thrown away half of the array and you'll only be looking at 500,000 elements. In the second iteration, if you don't find the value, you're going to be throwing away one end of the array or the other, and you're going to be now, instead of looking at 1 million, instead of looking at 500,000, you're going to be looking at 250,000. So you can see how quickly you're able to converge down to that last possible place in the array, because with each iteration you're throwing away half of the array. And the rest of this, again, you can take a look at. You can figure out the code. If you understand the concept, you can figure out the details of it. That's the idea of a binary search. Okay, so what I'm going to do is I'm going to take a little bit of a break right now, make a couple of quick phone calls to people that apparently are wanting to talk to me desperately, and then I'm going to come back and add the final component, which will be looking at how we sort the array. We'll take a look at the bubble sort, and then we'll take a look at what you need to do in order to finish up this program. Okay, we're going to take a look at how the sorting algorithm works now, and I'm going to show you the program code and explain it briefly, and we're also going to look at the illustrations that I have in this Word document. Okay, so I'll be flipping back and forth between the program code and the Word document. So let me start with the program code. The sorting algorithm requires that we use 3 flow of control structures in a nested way. So if we look at the interior flow of control structure, it's going to be a one-way decision, and it's going to be comparing adjacent elements of the array, and if it finds the element on the left has a value greater than the element on the right, it's going to go through a 3-step swap routine that you've seen previously presented in 1400. It's going to go through a 3-step swap routine and switch the order of the 2 adjacent elements of the array. And so again, we have a decision being performed as to whether or not the contents of the adjacent elements of the array should be swapped or not. And that is all wrapped up in this inner for loop, which is going to iterate between 0 and the length of the array. Whoops, had the wrong thing. It's going to iterate between 0 and the length of the array minus 1 times times. Okay, so it will start at 0 and continue to go through the loop until the index variable fails the test of being less than the length of the array minus 1. Now, let me explain a little bit of that here in the graphic. So what's going to happen is the first time through, my index variable, and I'm using k as an index variable, k will have a value of 0, and then it'll be comparing the kth element of the array with the k plus 1 element of the array. And if they need to be swapped, it will. Then k is going to have a value of 1, and it will be still, this would be the second iteration of the inner loop. It'll check to see whether the k value is greater than the k plus 1 value, and if it is, it'll swap them. And then the third iteration of the loop, it'll be looking at the k value, comparing it with the k plus 1 value, swap if necessary. And then the final iteration of the loop, it'll compare the k value and the k plus 1 value, swap if necessary. And I can never let the value of k become greater than a value of 3. Okay, so you can look at the way the index variable is being manipulated, and you'll see that the way I have the for loop set up, in this instance, k will never have a value of 3, because I'm going to be comparing the k value and the k plus 1 value, and if I were to let that iterate one more time, it would attempt to compare the k value with a k plus 1 value that's outside the bounds of the array. So I have to be very careful in that inner loop to make sure that my index variable stays within the bounds of the array. And then that inner loop will iterate repeatedly so that all elements of the array can be compared, and at the end of the inner loop, what should happen is the largest unsorted value should get moved into its proper position. Okay, so at the end of all these iterations, the largest unsorted value, which starts out at 8 in the second element, should get moved to the its final location in the array. In the case of the largest value, will get put to the last position in the array. Now the array is not sorted at that time, but what I'll be guaranteed of is after I've gone through all the iterations of the inner loop, I will have the largest value in the array pushed to the largest element in the array. And then when it goes through the next iteration, so let's take a look at how that sets up. Once it goes through all iterations of the inner loop, it would drop out, come back to the for loop, the outer for loop. Okay, so I've got nested for loops. The outer for loop would increment the index variable, find that it needs to continue, and it would re-enter this for loop, and this for loop, when it is re-entered, will reinitialize. So k is going to go back to 0. So initially, the first 4 iterations, j has a value of 0, k has a value of 0, then 1, then 2, then 3, and then when we drop out of the inner loop, go back to the top of the outer loop, j gets bumped up, j has a value of 1. The next time we go through the loop, j will have a value of 1, and k will start over again at 0 and 1. So I'll be comparing again the 0th element and the element 0 and element 1, then element 1 and element 2, then element 2 and element 3, and element 3 and element 4. Okay, and the overall effect will be that the next largest unsorted value will be put into its proper location. Now, this works, but it's kind of inefficient. You'll notice that after not even 2 full iterations of the outer loop, the array is sorted. Okay, so by the time I go through the last iteration of the inner loop, on the second iteration of the outer loop, the array's in sorted order, and thereafter the outer loop has to be incremented again. I have to go through 4 iterations of the inner loop, and the outer loop gets iterated again. I go through 4 iterations of the inner loop. The outer loop gets incremented one more time. I go through 4 iterations of the inner loop, and beyond this point right here, there is nothing happening because the array is already sorted. So it works, the algorithm works, but it's terribly inefficient, and what I'm going to have you do is, once I explain how this works in code, I'm going to have you write an improved solution using a while loop, and I'm not going to say any more about it. I'm going to leave that up to you to figure out, but the efficiency of this algorithm can be improved dramatically with just a minor little change, and that change would involve using a while loop. Okay, now do you use a while loop for the inner loop? Do you use a while loop for the outer loop? That's the kind of thing you're going to have to understand the way this works and then make the proper substitution in order to answer the question. Okay, so let's go back to the program. And you'll see that in the button click event method, I just put the code to do the sort right in the click event method. Okay, so it's not maybe quite as nice as it could have been made if I'd used a private method, but nevertheless straightforward and easy to understand. You'll notice that I set a breakpoint. Now, how did I set a breakpoint? Well, I want to make sure this program is stopped. Okay, and when the program is stopped, if I want to break on a line, stop execution of the program, suspend execution of the program, I can click right here in this margin, and when I do, it puts a dot, sets a breakpoint, and then when the program runs, anytime this line executes, the program will automatically stop, and I can examine the contents of variables and arrays. So I've got a breakpoint at the end of the inner for loop. Okay, and we're going to run this program for a while and let you see how it progresses, and I'm not going to run it through every single iteration. Once you see how this works, you'll then be able to figure out what goes on beyond a certain point. All right, so let me start the program, and to make this work, I'm going to use some very specific data. I'm going to use the data that's included in this Word document. I'm going to give you this Word document. I'll send it to you via email. Okay, so I need to put in 38263. So I'm going to load up my int array 1 with values 38263. Okay, I'm going to stop this and restart. 38263, right? Let's see, one more time, sorry. 38263, yeah. Alright, so let me start it up again, and I will input 38263, and then verify that by looking at, remember this lists them in reverse order, so 38263, if I read it from bottom to top, then it shows me the actual order in the array. Okay, so the array has been populated, and now I want to sort it. So when I click the sort button, it's going to execute that code, and it's going to be hitting that breakpoint periodically. Okay, so it has hit the breakpoint, and we're at a point in time when j is equal to 0. At a point in time graphically here where j is equal to 0, and let's see, find this. J is equal to 0, k is equal to 0, j and k are equal to 0, and we're going to look at the array. So as I mouse over the array, hit the plus button, 38263, 38263, 38263. When j is equal to 0, k is equal to 0, these are the values that are stored in the array. Now it's going to go through a second iteration of the inner loop, and k is going to get bumped up to 1, and then it should have these values if I did this correctly. So there's every possibility that I messed this up when I did it manually, but let's see whether it works. Okay, so going back here and starting it up again, hit the run button here. It goes through another iteration of the inner loop. J is still equal to 0, k is equal to 1, and if I look in the array at that point, I have values 32863, 32863, 32863. Okay, so it has swapped the kth element and the k plus 1 element, as it should, because the kth element has a value that is greater than the k plus 1 element, and under those circumstances it swaps. Okay, so that's where we are now at the end of the second iteration of the inner loop, and still in the first iteration of the outer loop. So if I continue on with this and run, I go to the third iteration of the inner loop, still in the first iteration of the outer loop, and the third iteration. Okay, so start at 0, 0, 1, 2, makes 3, third iteration. And in the third iteration, I have 32683, 32683, 32683. The 6 and the 8 got swapped at this point. Okay, and then I go back and run it, hit the start button one more time. It's going to do the final iteration of the inner loop, at which point 8 has been pushed to the very last position in the array, the place where it should ultimately reside, and 32638, 32638 are the values. The overall effect of having gone through 4 iterations of the inner loop is that it has taken the largest unsorted value and pushed it to its proper location in the array. Now at this point, we have exhausted all iterations of the inner loop, and when I hit the run button again, it's going to drop out of the inner loop. It's then going to go back to the outer loop. J is going to be incremented, and J's value will become 1. Then it's going to drop into the inner loop again, reinitialize K. So we'll be looking at, when we hit the breakpoint again, J having a value of 1 and K having a value of 0. And if I look, K has a value of 0, J has a value of 1, and when J has a value of 1, K has a value of 0, we should be looking at the array in the same position, 32638. Hopefully this is right. And as I look at the actual array, oops, I messed up something. I didn't account for the swapping correctly. So it should be 23638. 23. Wrong one. 23. Okay, let me look at these values again and make sure I'm actually okay. So K's got a value of 0, and J has a value of 1. Alright, so I'm not going to update my roster, but you can look at what's going on in the actual array. It'll be a little quicker. Under those circumstances, it will have swapped adjacent elements the array. Okay, so I got these out of sequence, sorry about that, but it would have, when J is equal to 1, second iteration of the outer loop, when K is equal to 0, it'll be looking at the kth element and the k plus 1 element and find that the kth element has value greater than the k plus 1 element, and it should do the swap right there. Okay, so I didn't show that correctly. So we continue on in this fashion. You can follow the execution of this program code. I'll provide you with the code, and you can run it in the debugger. And what you're going to find out is that before the second iteration of the outer loop completes, not only has the largest value been put into its proper location, but then the second largest value will have been put into its proper location, and at that point the array will be sorted. Okay, now I'll run this just a little bit longer so you can see it's going to sort fairly early on, but because I'm using for loops and because they're fixed iteration and just keep going and going and going until they finally hit their limit, it's going to then go through a third iteration of the outer loop, and it's going to check adjacent elements along the way, and it's never going to find anything out of sort, and it'll be checking needlessly, and never swapping any values beyond this point right here. Okay, so it's going to get that array sorted pretty quickly, and I'm going to go back and run it. Okay, so we're at a point where let's see, K is equal to 0 and J is equal to 1, and the array again looks like that. The next iteration should take care of swapping the 6 and the 3, and at that point the next iteration it should be sorted. And when I look at the array at a point in time when K is equal to 1, when J is equal to 1, if I look at the array at that point in time, regardless of what my diagram says, then the values will be, the smallest number will be in the first element. Oops, still not quite sorted. Okay, the second smallest values in its proper place. Right now these two guys still need to swap. Let me run it one more iteration, and at a point in time when K is equal to 2, when J is equal to 1, if I look at the array, go on now, if I look at the array 2, 3, 3, 6, 8, at that point in time when K is equal to 2, when J is equal to 1, when K is equal to 2, when J is equal to 1, apparently I've got it right here in the diagram now, that's when the array is finally sorted. Okay, and again it will keep going and going and going needlessly beyond that point. So I have an algorithm that works, it's just that it's not terribly efficient. So what's the nature of the problem? Well, it needs to shut itself off, ideally it would stop and never go to this iteration of the outer loop, or this iteration of the outer loop, or this iteration of the outer loop. It's going through, needless iterations of that outer loop, and every time it goes through a new iteration of the outer loop, it has to go through 4 iterations of the inner loop. It's the outer loop that's the problem, and if there's a way to get that outer loop to exit early, then you could improve the efficiency of this algorithm tremendously. And this is also a problem that is going to become more and more problematic as the size of the problem, as the size of the array increases. So this is an algorithm that does not scale very well. and you can improve it tremendously by changing this loop structure. So I'm going to leave it to you to figure out a more efficient way to do this, and again, that's going to be the nature of your second test question. I highlighted all this because previously in an email I said I was going to give you a fourth project. That fourth project would be to make a change to some program code that involved a sort. I've decided rather than that being a project, that's going to be a test question. So you'll just simply have to provide me with a with the program code that's a improvement over this program code. Okay. All right, I think I have covered everything, and I'm going to go ahead and stop the video, put it all together, get it uploaded to YouTube, and then let you know that this is out there.